What starts as a basic build turns into something far more powerful. Stick around, by the end, this table is a whole different beast. This build gets some cool upgrades along the way, so don't skip out early. The final version's way better than what I started with. I'll be adding key features and improvements as we go. Stay to the end so you don't miss the upgrades that really bring this table to life. For some time I have wanted to replace my existing drill press table. It is always my practice, before purchasing a tool or a piece of equipment, to make thorough research of what is available. I always study and analyze the various available versions of the product I am interested in for their quality, specifications, overall design, construction and price. Finally, I read the reviews other parties have made because it is possible that important points have been made that may affect my decision. Having taken into account that I was planning to carry out upgrades and modifications, I chose the Axminster drill press table that fulfills most of my requirements and is very reasonably priced. For reference, I would mention that this table is similar to the one made by Wren. The drill press table arrived in a strong carton and with no signs of any external damage. On opening of the carton, all contents were found well packed. Let me show you what is included in the carton. All of the parts were found to be as stated. The measurements of all of the parts were taken, these appear in the next diagram. Remark, from the measurements taken it can be seen that the actual working area of this drill press table is 606 mm by 248 mm. The measurements of the parts of the underside of the drill press table appear here. For quick reference, T stands for thickness of the material. The drill press table 1 will be provided with 2 additional T-tracks. 2 will have a front-operated handwheel system that will be capable of raising it or lowering it. 3 will have a front-operated system that will immobilize any lateral movement. 4 will be outfitted with a new GS8020 fence that will carry its own workpiece stoppers and will be fully adjustable. 5 will have an angle bracket fitted on its fence that allows for drilling sequential holes equidistant to each other. 6 will have means of efficient dust extraction. In general, the drill press table will be capable of 1. Work accuracy, 2. Precision, and 3. Repeatability. It is the intention that by introducing the above we shall accomplish a no-challenge, clever work approach. My first upgrade entailed the addition of 2 T-tracks evenly spaced further apart from the center of the table. These would provide a more stable support for the fence and would provide more options for the holding down clamps for the different sizes of the workpieces used. This operation was accomplished on the table saw by repeated cuts. Masking tape was placed in the area of the cuts to produce a good quality cut and to avoid any damage to the melamine surfaces. Here one can see the 2 channels, cut on the top of the drill press table, for the new T-tracks, one of which is also shown. I tested to make sure that the screws holding the tracks are well embedded. Here I found out that the 2 measuring tapes placed next to each of the original T-tracks protruded slightly above the table surface. I'll have to see how this may affect operations. Here I have set up the original steel drill table on the underside of the new table to arrange a proper alignment at the mid-width of both of these parts. This is essential for a good balance of these tables as well as for their securing to each other. Here comes what some term the most difficult part of the project. I must admit that I found it straightforward to construct and fit the mechanism that raises or lowers the drill press table. However, there are some caveats, which I shall explain in detail. You will notice that I have drawn white demarcation lines which show me the exact location and path of the T-tracks at the top of the table. Obviously, I cannot drill or make any alterations within their paths. I drilled outside those lines and secured the cast iron table, the one in blue color, with 4 M5 bolts and M5 flanged hex drive screw-in threaded inserts. I have applied flat washers with split-lock spring washers under them. This method spreads the pressure load exerted by the bolts and makes for better securing. Once the cast iron table was fully secured in place, I tackled the aspect of transferring the winding movement from the back of the table to its front. Here come those caveats I mentioned earlier. One must accurately measure the distance between the top of this thin ruler and the center of the winding shaft, the white dot. Let's call this measurement K millimeters. Here the line EF passes through the center of the tube that runs from the back to the front of the table. Let's remember that this line also passes throughout the center of the winding shaft. Its height above line GH, which represents the plane of the table underside, must be K millimeters. This means that one must drill a circular hole through the support aluminum angle bar, that acts as the aft bearing of the tube, so that it satisfies this condition. In other words, the center of that hole will be K millimeters above the underside of the drill press table, as measured on the aluminum support. Next we drill an identical aluminum support for the front of the table. This means that the center line of the tube that runs from the back to the front of the drill press table lies K millimeters above its underside. Now that wasn't so difficult, was it? So far we have worked out how to arrange the height of the tube that runs from the back to the front of the drill press table. The next step is to make sure that this tube runs parallel to the edge of the cast iron table next to it. One will hold the two bevel gears at the back of the table so that they mesh fully and properly, then one will measure the clearance between the side of the tube and the edge of the cast iron table near point B. Next one will cut the side of the aluminum support so that this clearance is maintained. This clearance is relatively small, so one ensures that the aluminum support is long enough to accommodate two screws that will anchor this support to the underside of the drill press table, as shown. The positioning of the front aluminum support is easy because all one has to do is maintain the correct lateral clearance near point A. I have drawn a white line on the edge of the cast iron table for better visibility. Once this is done, the front aluminum support, more or less, positions itself where it should go. Just anchor it with two screws and don't forget those wonderful washers. We are about to complete this particular upgrade, but we must not forget that before we secure the front aluminum bearing and the handwheel we must insert two stop collars as shown here. Before their grub screws are tightened, these must be firmly pressed against the surfaces of the aluminum bearings to ensure that 1. The bevel gears always remain properly and firmly meshed, and 2. That the main tube cannot move to the front or the back, i.e., that no clearances exist. These collars must be well greased also. Here is the lever that I created for immobilizing the drill press table's lateral movement. Basically, I have added an aluminum tube to extend the reach of the short lever which came with the drill press. As it can be seen, the tube is secured to the short lever by means of a bolt and nut that are fitted through a hole drilled on both the tube as well as on the original lever. A soft handle has been incorporated at the free end of the aluminum tube. Here is the lever, in its upper position, i.e., the table is free to rotate. It is fitted to the drill press table rear friction ring. When this lever is lowered, it can be seen that the table is immobilized, i.e., no lateral movement is possible. Here is a quick demonstration of how the table is lifted and how it can be immobilized. Here the drill head and its chuck are aligned to the center line of the table. The chuck is arranged to the center opening of the cast iron table. This is the drill press table completed. Let's see what are the new items that have been introduced here. Item number 1, a GS8020 aluminum extrusion, 60 cm long, that serves as the new fence. This is supported, at its back, by angle brackets on the center T-tracks. Items number 2 and 3, 2 spring-loaded clamps, running on the center T-tracks. Items number 4 and 5, 2 long spring-loaded clamps, running on the newly installed outer T-tracks. Items number 6 and 7, 2 heavy-duty workpiece stoppers, mounted on the top of the fence. Item number 8, an angled bracket, which allows for drilling sequential holes, equally spaced from each other. Item number 9, last, but by no means least, is the mechanism for lifting and lowering of the drill press table. I am sure you will agree with me that the above constitute quite a number of upgrades and modifications. You may wish to see how item number 8, in the previous listing, works. Here is an example that can be used for different size holes, the centers of which are equidistant from each other and which are set at a certain distance from the edge of the workpiece. In the example that follows we shall drill 8 mm diameter holes, with their centers at a distance of 30 mm from each other. We need to have these holes with their centers at a distance of 40 mm from the edge of our workpiece, nearest to the fence. To do this we set the center of the drill bit at a distance of 34 mm from the edge of the angled bracket. You may ask why we use 34 mm, well, we use this dimension because 30 mm is the stipulated distance between centers of the holes and 4 mm is the radius of the drilling bit. We set the fence so that it is parallel to the edge of our workpiece and at a distance of 40 mm from the line passing through the centers of the holes we intend to drill. We shall drill the first hole and then we shall meters diameter, we shall then move our workpiece toward the angled bracket until the spare drill bit is in contact with it. We shall then drill the next hole. After this we just repeat the same process. Here follows a replication of this example using our table and its angled bracket. Here I must clarify that both the drilling bit, as well as the spare bit are M8 bits, i.e., they are both of the same diameter. I hope that you enjoyed this little demonstration. As you can see we have been successful in achieving the desired results. The last target for this project is the introduction of a dust extraction system. When working with a table saw the workpiece has to be moved. The same thing applies when working with a router table. However, with a drill press table the workpiece remains static during the drilling operation. I have found out that dust extraction through an opening on the fence works, but the end result leaves a lot to be desired. Mobile suctions with hoods that one points to the work area produce similar results too. These observations have led me to design and create a simple device which not only removes all of the dust and solid particles created during the drilling, but because of its enclosed nature, improves to a degree the efficiency of the suction pump used. Here you can see the simple construction of the tool I was talking about. It consists of 3 pieces of plywood and 2 rectangular pieces of perspex. I have cut channels on the plywood pieces using my table saw, so that the perspex pieces slide in. This is for easy insertion of this tool under whatever drill bit is used. I put the plywood sides together using CA glue and accelerator. I made sure that the suction is near the bottom of the tool base. Here you can see the tool secured against the fence. The long clamps have been employed to restrain any lateral movement of the tool. I have filed the tool's base so that the suction pipe is as near to the bottom of the tool base as possible. The shorter clamps have been employed to hold down the workpiece. I have used a Forstner bit on purpose because it generates a lot of dust as well as a lot of wood chips. Once the drilling has finished, the rear perspex rectangle is lifted. Look how easy it is to remove the tool. The clamps are removed and the workpiece is fully visible. As can be seen, there is no dust left. So, this tool has lived up to expectations. We have covered a lot during this project and I am glad that all of the results have been more than satisfactory. I hope that you enjoyed watching this video as much as I enjoyed making its different parts. Do let me know if you have any questions, I always reply. Let alone the fact that I appreciate hearing from you. I hope to see you in my next video. Have you got any questions? Do you have your own twist on this project? Drop us a line in the comments, we read every one. And if you found this video project helpful, click like and share. They go a long way in helping the channel grow. Hit subscribe. Ring the bell. And let's keep turning sawdust into genius. Thanks for watching, The Foundry of Ideas. Where great tools and jigs are built, one project at a time. Now I am going to measure twice, cut once. Then spend the next hour figuring out why it's still too short.